Possible to attach it to the receiver, transmitter. No, I mean, with the last year. Should that be? Yeah.
But should we wait for you?
No.
Okay.
Que vaya a review. Hoy,
Bueno, no, casi.
sí, bueno, digamos que estamos los dos en el mismo.
Hecho.
Yeah, but that's just otherwise people will just be coming and going.
Let's
Let's start.
Let's continue. Guys,
The guys that were from beginning, they are about to start.
okay, let's start. Okay. Guys, let's continue. Right? So we're going to learn now the syntax, right? The rules on how to write on this language. So, Martin, you want to go? Okay. So, you are now familiar with this code. This code. For those who know, now something that we have not said more clearly before, it's JSON. For those who know what JSON is, this data and this format for express data. Yeah, this language is fully based on JSON, which is very universal. That's the idea. So, as says here, this is called script DSL, domain-specific language. This is a language for wallets only, and communication to GameChanger Wallet is done through scripts coded in a JSON-based Cardano language, a language full of native Cardano-related functions. Right? This domain-specific language is called script. So the idea is that any app or this device connects to the wallet. When you scan the code or you click on the link, this app connects to the wallet by typing and pressing Jesus script. But then, and this is a nice thing when you're building, then you can also have the same technique, the same compression technique on URLs or QR codes for replying things back from the wallet to the via or to, for example, a hardware device, which is optional. As you have seen, as you have tested before, this connection was from the via, from the hardware to the wallet. Unidirectional, just one way. But if Martin would want to, he would have programmed something like this for this code to generate a customized result in JSON also, in the same format of JSON, for returning data back from the wallet to the device or the device. Right? Please remember that this is also for the app. I mean, any app can just connect as Martin says. That's important. It's not only for devices. Right? Okay. Okay. So, on Jesus script, we can say everything you will be watching, reading on this language is a function call.
Okay.
For those who know a bit of programming, a function is like giving an order to the computer, right? A function is like, hey Martin, walk straight ahead. Walk straight. Now functions can receive like arguments. We call arguments to some sort of data we can pass to the function to, give more specific orders. Because if Martin has to walk how much? I mean, how many steps? So
5 steps.
For example, 5 steps. So I can give an argument, a piece of data there, like a 5, maybe a number 5, to a function walk. So Martin will just walk 5 steps, right? This is what a function is, and this is what an algorithm is. So this script has functions which are expressed this way. Because I don't know who knows JSON, and it's okay if someone did not know, but who knows JSON already?
Just the name.
Just the name. Okay. You? Okay. That's good. You? Yes. Yes. Okay. So we're not going to get too much deeper into JSON, which is not difficult. But like on every language, you have rules. You have to start expressing things with some tokens, some characters, and then you have to also close some wraps, right? Some functions or blocks or whatever. Every expression you do, you have to close it with another character. For example, on JSON,
I do know JSON.
you use these characters for opening and closing objects on JSON. This is an object, okay, on JSON. So maybe I'm not going to explain too much JSON. No, wait there. I mean, no, stay there. So maybe I'm not going to talk too much about JSON, but keep this in mind. A function, another like walk, is expressed by opening these brackets and closing this bracket here. The first part here of this expression is a property on JSON, which is always type, is always the word type, is expressing which type of function or which function you're going to be calling. And after this part, on this other part, you put inside always everything that's text. It's wrapped from quotes, double quotes. So on this part, you put the name of the function. So on this silly example of walking, here we will have it said walk. But on this exact example that is a real function, Jesus script, we are asking permission. We're asking permission. The DApp is asking permission to the wallet, to the user actually, for the wallet to share the user address. So get current address, right? Okay. And on this other example here, we have another function which is not exclusively for Cardano, of course, it's a very generic thing, which is for defining just pieces of data. Like sometimes when you code, you need to parameterize things. You need to, for example, if I need to store these 5 steps that I want to pass to this function, the walk function, I need to store these 5, this number 5, somewhere, right? So there you use things like, on other languages you have heard maybe constants, variables, just pieces of the memory of your program that will store just somebody. Okay, for example, a number 5, for example, a text, for example, whatever, right? So the function, because type, once again, type defines it's for calling a specific function. So type data is like a function that is just for allocating, storing data on the memory of the program. Right? And Martin is like.
Uh-oh. We'll be back.
Okay. And remember the arguments I was saying, like passing the number 5? Okay, for passing arguments, any other JSON property, like value in this case, and you can have multiple other JSON properties on these functions, all of those are going to be arguments. So in this case, value is an argument. And inside this value argument for the data function, you have just a bunch of data. Of data and a piece of data, which is random, I don't know. It's whatever a developer needs to store. Okay? So this is the basics. If you remember this is a function call from a get current address function. And if you remember this kind of syntax, this is, for example, a call to the data function, passing this value argument. That's it. Everything you will see from now on the language is a bunch of functions and arguments. And just that. It's quite actually simple if you think about it. Okay? Okay, so now imagine for those who knows programming, this can be called like subroutine, like a block of code. It's like packing, right? Packing a list of commands, functions inside like a box, like saying, okay, please store this list of orders in a sequence, in a specific sequence that I want to execute it. And I want to handle that piece of that list of functions. Maybe because I want to replicate it, or I want to have it just for ordering my code. Like for those who want to order the code a bit more tidy, maybe more beautiful, maybe you can just, categorize like, okay, I will pack all these commands and these functions into just this box. And then I can, it's free for the, it's something that the developer,
Being kind.
yes, can decide to do. Once again, who can tell me the name of this function?
Script.
Perfect. And who can tell me the argument? What's the name of
Data.
What's the name of the argument?
Data.
Random. The name of the argument is random.
Is it a function?
No, remember. Remember.
The name of the argument. Okay.
This is a function. And everything that is not the type property are arguments.
Okay, but then downstairs you have result 01 type data. That's another function.
Yes, you're right. Yes.
Okay, thank you.
But what's that actually? That's a good question. She's always like 3 steps ahead. You're great.
No, sorry.
No, don't be sorry. It's perfect. This is a block of code. Once again, this is a box for calling other functions. So what she was reading actually are the other functions, the inner functions stored on this block of code, right? Which is, for example, the function
Data.
data, which has the argument
A.
The argument
The argument value and it will store A.
And the value stored is A. So what's this then? What's result 01, result 02? It's a bit confusing.
It will be the variable.
It's an argument for one.
Exactly not. Exactly not.
It will
Sorry.
be the
But it's
variables.
not. It's just,
They are kind of
it's
variables.
just a way you can just express your code. You can just, this is arbitrary naming. You can put here whatever you need for make your code more real.
So that would be kind of a
in this
variable
case,
then. Es una variable.
Actually, this is just,
La función, el argumento y variables.
Forget what this is right now. Forget
Yes.
what this is. The whole thing is an argument. Keeping that in mind,
Okay.
keeping that in mind for those who knows JSON, this the value that you pass on this argument is or a list or an object, or a JSON list or a JSON object. This is why we are using the JSON object mode for passing some functions. So why? Because you can just here an arbitrary name for each piece and for each function you want to list there, and it can be handy for programmers for just understand the code. It's more
Yes.
readable. Okay. But check how, for example, in this case, this case, It's kind of similar. Forget about this line. You have this run argument,
Name.
this run argument, and we are passing functions. Check how you can just express these functions on the same line, or you can just put one down below. JSON does not care. If you start with this bracket and you close with this bracket a function, it's valid JSON. It's valid for the language. It doesn't matter if you stash everything on a single line, or if you are using
perfect.
new lines for each line. It doesn't matter. Okay? So it's just another way to show it. Here, can you tell me the names of the functions? That are
Get
in-
name, get currency address.
Yeah, exactly. Get name, get current address, and get current slot. Okay? So these are real functions on the Jesus script language. Right? But the difference between this image and this one regarding arguments of the
Okay.
script function is that that image has a new argument. Which is
Hey, I'm an argument.
quite confusing because that argument, the name of the argument is actually args arguments. Why? Why? Because we have these three functions here inside this block of code. What if we want to pass an argument? We want to pass this kind of data, distribute this data to all the childs, all the child functions, all the inner functions, these three, right? If we want to do such a thing, we need to pass like arguments to these functions.
Okay.
And we can pass one argument to all these
Oh,
functions using
by defining
args.
it there. Okay.
Okay, for those who knows programming,
Perfect.
this is kind of something, very.
That's from
known.
JSON? No.
What?
That's esto es del lenguaje este.
It doesn't think.
Okay, good.
Exactly. So, for those who knows programming, this is something quite common, passing arguments. But it's okay for those who are learning. It's not super important to understand these arguments thing. But just please try to understand and remember the syntax. Understand that these are functions. This is the most important thing. So then, when you read the code, it can be a bit intimidating at first, but then you start thinking, hey, I read a type here, meaning that I know the name of this function. Now I can recognize this piece of the code. It's a function. Okay, that's the important thing. For you to recognize what you're reading, if it is a function or if it is something else. This is the most important thing. Just to land.
Es un contenedor eso entonces.
It's like a container. Yes, it's como un contenedor. Exactly. Okay. Let's continue. That one. Okay. So remember what Martin was showing you, the user interface of this DApp connector, of this that every piece of the script of the code had a representation of the UI of the wallet. Okay, remember that cache or cache part on this status tab on the advanced section of this DApp connector UI user interface. Okay, I told you that were the memory. That was like a snapshot, an image, a live image of the memory of the wallet, the memory of the program, right? So when you want to extract things from, remember that I told you that, for example, this device can trigger a connection to the wallet can process things, and then I can return things back to the DApp. Okay, how do I return things back to the DApp? By just using the export as argument of the script function. The script function, remember, is the ones we were reading on the other slide. So by just adding a name to the export, just adding a name to the export, like saying, okay, I'm going to export a bunch of data. I'm going to name this bunch of data like my first export. That's the name. by just doing this, you're authorizing. The developer is requesting the wallet for returning back to the DA a piece of a response, right? A piece of JSON data back to the under this name. So if you actually can capture this response, for example, in this case, it will look like this. So now is a good time to understand a bit more how this thing works regarding timing, regarding the order of execution of each function. So this is a block of code. It's a box that contains functions. There is a sequence of 3 functions. Yes, which are what functions are you reading? Data. Okay. So the first function, we are passing the value A for what? For letting the function data to store A on the memory. If you are going to export that simple piece of data back to the real, the result 01 line here, because we call this line result 01, right?
Yes.
What's
It's
the
A.
result?
A. Perfect.
Can you see the correlation between the code and the result? Okay? And for the second one, what's the final value? Third C. Are we okay?
Yep.
I mean, it can be a bit confusing, but let me know if you're okay. You're okay? So, this is why this arbitrary naming is important, because you can just name things, right? As you need. And only if you use
Okay.
you are actually getting things out of the wallet. If you're not using Exportas, whatever happens on Las Vegas
Stays in Las Vegas. Okay.
which is very important for privacy preserving the apps.
Okay.
Okay, that's important. It's not just a random mention of this. If you don't put Exportas, nothing will get out of the wallet.
Ah.
I mean, this can sound like I'm explaining
Yeah.
just one another language, like just one more, technology, blockchain technology. But at the end of the day, we will be wrapping all the concepts that you will be learning. You will understand that this language has a lot of Web3 values, Web3 principles, very, very, burned at the core of this wallet, at the core of this language, which are not minor things to figure out.
So you mean to say that that's the only way that you actually are able to send data back to the...
Yes. There's no other way, unless a user manually do something, then there is no other way for the wallet to just stop.
Go back to the
Exactly.
coin and get whatever.
Exactly. And this is the first step for all the privacy preserving things you can accomplish with this language. Because there are much more. Without time, I like quite much. Yes.
For most DApps, there's
Yeah.
no reason to
Yeah.
this communication.
Yeah.
So it's executing scripts and contracts. It should just work on itself.
I mean, maybe a few of you have already used, for example, any other programming language in Cardano or another blockchain. But the thing is that if you have done, at the end of the day, you will be able to compare the two models. You will get to understand something that is very important. That is, here you don't have a back and forth communicate, very frequent back and forth communication with the both entities.
Okay.
It's the app and the wallet, which means that you are actually packing your intentions as a developer on the GC script. Your intentions, and I mean, a bunch of your code with a very clear purpose, a very transparent purpose. You're packing all this stuff into your code, and that's it. And then it executes, and then if you want, a reply will go back to your DM or not. So, but this is not like the other systems that are popular nowadays in Cardano, where every single thing, like for example,
Back and forth, back and forth,
yeah, back and forth, and on that back and forth, sometimes
You're vulnerable.
you don't have a button to say, I agree.
Okay.
I want this
To happen.
This single thing, this single function. I accept this single function to run. No, you have just a connect button, and a connect button allows
Shows everything, okay.
exactly. It's approving everything, and you don't know exactly what's going on here.
Yeah. And with execution, you mean execution in your browser,
Yeah,
on your computer, or not somewhere else.
yeah.
But it'll only do the automatic execution on that amount you set, right? So if, for example, if it's like on Ethereum and you sign once, then you will do the transactions all the time.
Yeah.
And that's how you get paid most of the time. And in this case, it's only that certain amount.
You get the summary with the effect on your wallet, and that's the only thing that
That's
can
the only
happen.
thing you can't do a second transaction afterwards.
No.
Because that's
Exactly. And let's do something because we don't have this exact image screen capture here on this slide. The key is on your computers, guys. Is check your computers right now. Check the image you left the last time you were dealing with the wallet. Can you see? So can I use yours?
if it's a different one, you have to.
No, but I want to show you something. Sorry. It's someone who can. Everyone has closed.
I need to close it, it's just.
The transaction, I got the transaction.
I want to show you.
Press something.
Okay, so.
Oh, okay, got it.
The QR
With
code.
the transaction? Transaction?
Yeah, there.
Yeah.
Can you read the quarters?
Oh, the colors, yeah, it's execute code X, one time, build transaction, one time, sign transaction, one time, this is a transaction, one time.
So, but what you're actually reading is
It's all the different transactions.
functions.
Function, yeah, function, different functions.
So each function
As a sign,
has a permission,
yeah, so you have to sign.
which is up front, shown to you before you start executing.
So you're combining them in one.
Exactly. So in one execution, you are presented before executing the code with everything that VIA wants to do with you. With you.
So depending on the action that you take, if you push the button, whatever it is.
Exactly. This model differs from these famous connects in such way that here you don't trust brands. Here you have to trust code or permissions.
And yourself by reading.
Yeah, like
Exactly.
you can auto.
Exactly.
Because you can still think, oh, it's safe, and then it says 20 times and execute 20 times. Oh, yeah, it's okay.
I have to get this airdrop now.
This is very important.
Yeah, it'll save the lifetime of, if, for example, if you use a ledger, then it's.
So now I understand the name of the wallet, GameChanger.
GameChanger. Oh, yeah.
It sounds quite ambitious, but they want to present another. I won't talk too much about this, but this wallet was like the second community wallet created back then in 2021.
I want to use this wallet, right?
We did not know. We were figuring out how to connect Cardano to the world. So two wallets appeared almost at the same time, Nami and GameChanger. Nami first, 2 weeks later, GameChanger. And the thing is that now you can see that our model was very different. And this is why this wallet is different. It's not we are rebels. It's because also we were figuring out very early. We did not know what was going to happen. Right?
Absolutely.
So every function on Jesus Christ requires a permission or more than one permission for you to review prior execution. And that's the difference between blind trusting the famous connect button on
And that's why
here and on Ethereum and everywhere, because it's a
Yes.
practice
You
that
don't-
is
you don't
common
know-
to
yes.
all the world. And
You do not know what you're doing when you go connect. In this case, you know everything. That's very, very good.
and now,
Very good standard you're bringing.
Nice, thank you.
Perfect.
And I'm going to.
We're gonna take it everywhere.
Would be nice. And
Good.
this is the last thing I want to divert from this slide, but it's important. So, did you know that all these other wallets that depend on this famous connect button, most of them, not all, most of them, are relying on injecting code, JavaScript code, automatically without your approval
Yeah.
to every single web page you are
You visit,
browsing.
yes. We're selling your information.
Can you guys tell me? Can you tell me what happened when you scan this QR code? Something executed automatically without your permission, or it
No.
was asking to continue on?
Yeah, multiple continues, yeah.
Yes, all the time. That's right.
There is no code injection under this model.
Okay.
All that what is stored on these URLs or QR codes is fully audited.
Your key is your code. That's
What she has said
Yes.
is the Web3 value
Yes.
that motivates all these crazy.
perfect.
Because actually, if you are not fully in control of what's happening with your wallet, you can have control of your keys in theory, but you are kind of blind trusting an intermediate that is telling you what's good or not for you. Here,
No, which
You
is
own
okay.
your keys.
I could have one first variable, or I don't know how you put it here. I said a long time ago to code, so I'm starting again now. But you could have one. Okay, I trust this guy, and everything is continue. I could do that if it's your code. I would just
Yeah,
go with that.
They can integrate a service because you got a service that checks the wallet address if it's a no wallet. I forgot the name. Game Wallet also uses that service. It's Cardano Shield.
okay, but still,
You still have to.
Still, what happens if the
They-
brand, the team you are trusting
Yeah,
gets
gets
hacked?
Yeah.
okay.
Here.
We
Yeah, it's
here,
about.
Oh
do you
right.
remember the
I'm a woman.
verify?
Yes.
Don't
Don't
trust.
verify.
Verify.
Well,
Yeah, don't trust
But
verify.
this is don't trust,
Verify.
verify.
Yep.
Because even with me, never trust what I'm
Oh,
saying.
I say
what
the
I'm
same
doing.
thing.
Read the code.
Trust the code.
Even for me, don't blind trust ever. to
I
anyone.
will say where
Of
you
course.
are, of course.
Of course.
But the
If
truth
you
is,
want trust.
I need to make it quicker, so I'll trust.
I know.
Just
But
less clicks.
the idea is that
Yes.
whoever wants to verify should have means to. And this is the idea. Always transparent. Everything that is going to happen on your wallet is there for you to first review. And of course, for developers, this is amazing because it can just foster a huge open source collaboration or collaborative ecosystem for Cardano building this way. Because everything is right there on a universal language, not something specific to JavaScript, to Rust, to Haskell, to this is universal.
So you're basically every transaction is kind of a smart contract, and you sign it once and then it's basic.
Yeah, the thing is that this is running on your wallet. Remember that. This is running on your wallet. And part of this will eventually run or impact on Cardano, right? On the protocol. Which is important to get that part because guys, this also helps decentralizing the apps. Because this part of the DApps are running
Obscure mode.
but are running where?
In
On
our
user
computers.
devices.
Yes,
not
on
on
our
a
computers.
centralized backend, not on a centralized application. This is running client side. Okay, let's move on. It was
We
important.
get it.
It was important.
That's la realización he had to do.
This is what
So
you
I
were
lost
asking.
my wallet now.
So remember when we have this, for example, these free functions listed on a block of code. Imagine that each function, as shown before, has a result, right? which is stored on this cache memory. So what happens if the subsequent functions, like for example, the function number 2 on the list, needs to use on its arguments part or the entirety of the result of the previous function, like making plumbing, like connecting one function to the other. How can we wire chain these functions? How? So here is where another concept appears on this language, which is inline scripting language, ISL, which is, for those who knows JavaScript, JavaScript is a subset of JavaScript syntax. That what is like just a piece of text that you can embed right on the JavaScript code for doing things like, for example, doing this plumbing, like connecting the result of one function to pass this as an argument for another function. So in this case, this example, and let us know if you can read this. Maybe it's very tiny.
Very little, very small. I think.
Very small.
I can read it, right?
Maybe this. Okay.
Ah, perfect.
It's a bit ugly. Bit pixelated. You can read it. Probably. So, forget about this part. It's not relevant right now. Here we have this script, this block of code, right? Here you have two functions. You have a type and another, so this is a function. You have a type macro, which is another function. You have a block of code with two functions. One first, next the other. The idea for privacy preserving matters is that sometimes you know what the hash is?
Yep.
The
Yes.
cryptographic hash. It's just an alphanumerical representation or a numerical representation of a data, which you can create this hash, right? From, for example, you can use my name. You can hash my name and create like an alphanumeric code or representation of this name. But you cannot go other way around. Having this hash,
You cannot know
it's
the name.
impossible to obtain my name. So it's one
Wow.
direction, right? This is how Bitcoin is built and everything.
Yes. SHA-25.
The basic. Yeah.
256, yes.
So this is important for privacy preserving matters because you can go one way around, but not the other. You cannot obtain my name from a hash, but you can obtain a hash from my name.
Right.
So sometimes, to avoid exposing directly things like your Cardano address of your wallet on a DM or on chain maybe or whatever, you maybe just need a reference, somehow a reference, a unique reference to, for example, my name, my address. You can hash it. But the thing is that if you need the wallet hash, wallet side, the DM maybe
Also has that.
no. That's the sorry. No.
No, it's
That's the
okay.
key. That's the key. The DM does not need to know the address. Maybe it does need to know the hash.
Yes. No, okay, absolutely. So when they do the hash, they have both parts of the information.
When they
That's a problem. In this case, it's me who keeps my name and send only the hash. That's perfect.
But it will be on
I
chain
like
with
this
your
very
address.
much.
It will be on chain with your actual address.
No.
So the DM doesn't know his.
but depending on what's your DM, depending what you want to do. And in this case, it's a silly example because I don't know. Maybe this does not apply to what you want to do. But keep the idea, the design pattern behind this model. You can process wallet side stuff to avoid leaking private information back to the apps.
So this is perfect for Historia Clínica.
It's perfect for
For a lot of things,
A
but
lot
for
of
this, it's like, I understand, I know. It's something that's the idea I am caring about now. So.
So those who care for privacy, like check this 3 times, 4 times, because there are a lot of privacy preserving properties behind this model, which you can use.
So just as an easy example, if I, for example, go to JPG store and I want to see my profile, I have to
share.
Connect, I have to connect,
Yeah.
and that part should have been hashed. So they,
If you care about privacy,
Yes, we should know.
imagine a JPEG store user experience where you deal with JPEG store, but actually you're never even directly to JPEG store,
that
or you are.
yeah.
And this is the beginning for building this kind of applications.
Unless you buy something and then the
Yes.
transaction goes on.
Just but actually, if you have been scanning your code and you are doing what you're saying, for example, it's hard for the Apple store to know your IP address, to know your device, which
Okay.
so that is where this privacy is happening, because depending on your client, you are not leaking, for example, your IP address directly to them, so they cannot match who you are with your financial persona on
Because
the chain.
it could be a new wallet and there's another duplicate. Okay.
Copy it, airdrop it.
This is so.
This is just thinking
No,
things
no, no.
differently from the very beginning.
Yes.
just because this is the version 2 of the wallet nowadays. But from 2021, this was very much, I mean, was much simpler than this. But actually was the same principle. Wallet side, off-chain building, we will get there. Like wallet side processing of certain things that we usually tend to delegate to DSLs.
No, it's
If
like
we
when-
give too much power to DSLs,
No,
we
it's-
are making our intermediate.
It is the same thing when
bigger.
y como las computadoras personales. It's like when the IBM came with PS2. This is the same thing. I get the power.
Now, and
I like this.
And there is something, one thing I'm going to say. You can fully, and this is very important. Now you, if you think about what you have been doing on your devices, you can now maybe get the idea about getting rid of the deal. Like, for example, if this QR code is static, it's not changing, because this QR code changed for each one of you to scan it previously, for it was static.
It was static.
It was static, but it adapted perfectly to each point of view, for your individual points
Each-
of view, for your wallet, addresses and funds. So this means that
Eso es
once
tonto.
once you, in some cases, when this connection is generic enough, is constant, you
Yes.
can just make a copy of this connection and get rid of the intermediate. So it's an almost direct connection between the user and the chain itself. Just the wallet, of course. You need the wallet at least.
Yeah. You
The
shouldn't
wallet
call it a wallet
No,
anymore. You have to call it
no,
app.
you can say it's a mix, but it's important to keep in mind that this is a wallet. Because if we get rid of that category, I mean, we're saying this cannot be handled by the app. Sorry, by
Sorry,
the wallet.
I don't want to bring this
Okay,
maybe
okay.
confusing, but philosophically son aplicaciones
Okay. Okay.
o herramientas. No, we argue
we
that
have to-
some of the time.
Here, the vice button. Okay. So,
Here is the code we just get the others in the version.
yes. How we do it? How we do it? We on the first line here
Ah, okay.
We-
You're using 512. Wow.
require permission from the wallet to share the user address, and this will be stored on the memory of the program. And then the second function, which is macro, will run because this ISL thing code is here on this.
So nested, yeah, could be 3 lines.
And here, as you can see, here is a bit different. You have everything is also a function here. It's similar, but the syntax is different. You have the name of the function, and then you wrap arguments inside parentheses. This is the tiny difference between the two languages. And here is a SHA
512.
hashing algorithm over whatever we pass as
in
argument.
cache address.
And what are we passing as argument? We are calling another nested function that is called get, because it just do that, it gets stuff. From where? From the memory of the program. And the memory of the program is called cache. So you say
The memory, that's the memory,
vote address,
because it's get current address.
you're
Should it?
accessing
Address.
what you
Perfect.
named here. It's like
Okay.
naming a variable.
Okay, that's a variable. Good. Yeah.
Okay. Don't worry if you don't get this right
Perfect.
away on the first time. Don't worry, because this is you get to master this by doing practices. But keep in mind that when you read, especially when you read get and something between parentheses, is the string we use to make plumbing, to connect the output, the result of one function to another one. Okay? And this is where it differs strongly from, for example, CIP30, which is the standard that most wallets and dapps are using, for example, on Cardano, where you cannot do this, and where you miss a lot of privacy preserving possibilities for your code. And once again, because we set export as here, under my private wallet data, then the result on exports is my private wallet data, and here's only the hash of a user's hash. Because this code, remember, is generated, works on your wallet, and your wallet, and your wallet, generate. The idea is to express intention, not only express, some code that only works for you. It's a generic code.
And also you will see what is going to be exported after a transaction. And then you can still cancel.
Say it again. Perfect. Say it again.
What?
Say it again because
I was
it's great.
writing.
You can see at the end of your transaction, you have to confirm that what you're sending back as export is
Okay.
still what you want. You can cancel it.
Good. I still have the potestad. In Spanish it's potestad. So power
To cancel,
to cancel.
data back to the data.
It's still mine. Good.
So,
Perfect.
so you maybe are watching, you're reviewing this UI, the F1 active UI, you're watching that at the end of the execution, you will be presented with the information that
The result.
the wallet, the result, that the wallet should be connected to the data. But if you read something that you don't like, or you're not trusting the process, just cancel. That's it. Or you, for example, you can copy that.
Full transparency of the whole process.
Transparency, privacy preserving, giving back control to the user of the user keys.
Sí.
So there is nobody forcing you to do that. You have
Not
full
cheating.
control over you.
Perfecto. A la luz del sol y los ojos de Dios.
Very Bitcoiner.
Es en realidad es muy free will. Es eso. Perfecto. Amo esto. ¿Corren otro? ¿Corren otra?
Hay que hacerlo. Pero se puede. Yo, por eso te digo, hay muchos
Sí.
valores web 3. Y es apasionante.
Me voy a ocupar de que entre a Jessica. ¿Qué Bitcoin?
Have you the documentation for cache
Documentation for
cache fields?
cache.
No, you have a cache where you get
Cache
the
de
address or other fields of the cache.
No, the thing is that you design the cache. The cache is the actual
The memory.
the memory that you are creating when the code is getting executed.
This is the cache.
This is the cache, and check this. This function, remember, script, run. Here you have a list of functions, right?
So,
You name this one stage 1 build transaction because you wanted to name it.
I was, this is called stage 1 build transaction.
So this is where this mapping happens, where whatever you code in the order you code is important. Whatever you code in the order you code it here, is the same on the results. It's the same on the results. This we call isomorphism of the language. Because whatever you design here, it will end up creating a data structure that mimics your design. Isomorphism. Like a kind of a mirror situation where you have the same kind of structure that what we code and on the results. So, yeah.
Next one?
Okay, this one.
Yeah.
Are we okay with
I lost the window. Perdí la ventana, se me cerró. I lost, no tengo la wallet, no sé cómo llegar de vuelta.
entra en GameChanger.Finance.
Perfecto, gracias.
Y ahí,
Ahí ya me las arreglo, problema mío.
pero no, porque tenés la versión mainnet y testnet. Entonces,
Acá.
esa, entra ahí.
Thank you. Vamos a poner una estrellita.
I've been helping
Primera de todas las cosas. Es mortal esto. Mucho más.
Exagerado. Como sabes a muerte o nada.
Ponemos esto en RC con el
El backend
docs.
está descentralizado también. De la wallet. No vamos a llegar ahí. Pero es una exageración de Web 3 que no se puede. Como 3 años y medio de mucha.
Muy bueno.
Do we go through this one? It's a little bit extra.
Yes, no, it's okay, because this one will hear this code. We will be actually doing something interesting.
Okay. Paid me $2,000, for example.
Which is payments. Exactly. Which is why we're here to use, the blockchain for doing transactions. But can you go one back, please? There. So this is collapse. This is the basic structure. 1 second. So this is a block of code. We have 3 functions that will be called here. This is the basic structure for any transaction on maybe any
Economic transaction.
maybe any blockchain, but
A
especially
blockchain
Cardano.
transaction. Perfecto.
In regard of it implies a building stage where you design the transaction. You design, for example, if you want to make a payment, you have to write instructions for the payment for this, and then hand this information to the blockchain, the nodes that conform the blockchain, right? So, to write this piece of information, we always say like this is like building the transaction. This is the first stage of most of the dapps you use every day. The second one, because until here, sorry.
Back?
How
fast?
He's covered.
Yes, you're in a hurry.
Here, this is nothing. And here we're safe. Our funds are safe. Because nobody has signed anything. So nobody has approved anything. So until here, it's just a piece of data. But then on stage 2, when we will be using our private keys of our wallets to sign this piece of data, which is the transaction, until here, this stage is where things actually start to make sense. And you put, you approve the spending, for example, of funds or doing something else with your private keys. And even then, even here, nothing happens yet. Because you can just throw
Reverse
this away.
everything. Okay, cancel. You're not sending.
Exactly. If you're not sending this to the outer world, to the blockchain, this can die with you on your device, on your computer, nothing will happen until or unless you submit this piece of information that is already signed with your signature to the blockchain. So 3 basic steps that makes, for example, a payment on blockchain possible. 3 basic building steps. So let's now
Yeah.
differ. Martin is like Formula One.
Yeah, con la pinta. He went to the first position.
Aston Martin. His name is not.
Adriano.
Do we have to approve submit also?
Yes.
Like sign? Or after signing, we
Submit, yes.
pass.
No.
Or we have to approve submit.
Yes, that's a good point. So some functions, you start. Remember the continue button at the beginning? You are agreeing there to start executing the code, but some things are a bit dangerous. For example, when you sign a transaction, you can be, signing your death sentence. so
Like getting married, for example.
But
You could be
so the idea is to also, the wallet also asks you right there, once again, if you want to sign the transaction. And you will be presented with a, like on any wallet, with a view where you can, review every single piece of your transaction to see if you are agreeing with it. So, yes, so some functions also have extra extra steps that you have as a user you have to follow. You have to confirm, for example, review and click on sign when you call the sign function. But on the build function, nothing will stop this function unless you don't have finance. Nothing will be presented to you because it's harmless. Building transactions. I mean, I can make a transaction right now, spending all Charles Hoskinson's funds to send those to me, but without his signature. Yeah, we cannot do anything. So he's super safe. Okay. So now this is important. The build transaction function type build transaction is one of the most we can say complex functions of this language because you can do a lot of stuff. Cardano is it's a very feature-rich blockchain where everything is bundled there for you to consume. Different actions, like not just sending. Of course, you have smart contracts, you have staking, you have now governance features, you have a lot of metadata. For example, you can store data right directly on blockchain. So every single transaction feature is here for you to consume. But let's only keep the basics today, which is the outputs, if we can say feature. Outputs.
One question. Where's the part of the get current block? Normally there's a get current block. You first have to get the current block where you have to put a transaction in.
Get current block? Like knowing
The current block?
Yeah, or
The
the current
blockchain.
you mean
The slot?
the current slot.
The slot.
Current slot.
okay.
Yeah.
Current slot. I mean,
The TTL? Is it?
Yes.
Yeah, because when you do a transaction, you first have to check the blockchain and then
You can set TTL.
this is a very good question. I mean, for some things, and this is important, some things by default are automated for you, for not worrying about things that makes no difference. So you you want to make a payment. Why you would care for knowing which? So it's a great question, and the answer is you can consume, for example, ask for the current block, slot actually, and then configure the TTL time to leave of the transaction. But if you don't want to,
you don't need to.
this defaults to nothing. So it will leave forever.
Only worry about the things that you need to worry about.
Exactly.
Yeah, make it simple.
Exactly. So the wallet makes it simple. So this is why, if you have been building transactions before on Cardano by code, and you know, and he's laughing because I bet he knows what I'm talking about. Inputs, coin selection.
Yeah, I hate it. I I wanted to join the NFTs, man.
So it's hard. I mean, to be honest, Cardano is a beautiful blockchain, but dealing with the lower, I mean, the deeper you get to the chain, it gets hard. My job as a tool maker, as a maker of this wallet, is to make life easier for you. So if you don't need to mess with that deep stuff, it defaults to the basics you need to just make it work.
Yeah, that's true.
So in this case, coin selection meaning, I mean, we have not covered UTXO model. I think we can keep it this way for a bit longer to keep it simple for those who don't know what UTXO model is. But the idea is that the wallet have by default some coin selection algorithms that are being executed every time you need to build a transaction. And those are managed in such a way, and this is another nice thing of GameChanger, is that you can have on a single script more than one transaction.
Well, and then you have
I'm not
less costs,
Yeah.
a lot less fees. I like that very much.
But I'm not. She's right. She's saying something else, but I'm meaning not outputs, transactions. So you can have multiple outputs on a
okay.
single transaction. This is an output.
Okay.
Multiple on a single transaction, or you can have also multiple
Transactions in one output,
in one script.
in one script. Okay. No, I got it wrong. Okay.
Is there a size limit to the scripts that we can use?
That's a good one. In practice, there is a size limit imposed by browsers. But we will get imposed by browsers.
Okay.
In practice, I mean, there is like no standard. It's like there was some values there on the internet and some standards, but each browser decides differently the
Yes,
size.
what they will allow
So
you.
it's important what you're asking. It's a good question because, of course, we build a huge, very large code. We will have issues everywhere. Your codes already are a bit ugly because of the the amount of
How they look.
data we're stashing there. But we have features for solving that.
Gabriel, were you asking
A little
about the
more.
size of the UTXO transaction?
Not the transaction limit, because now we can chain transactions, right? So each transaction would be 16 kilobytes. The question is the script that manages
The length of the
transactions.
the length of the script.
Where there's our limit,
Yeah,
right?
as
Script.
far as
Right,
sort of
right.
examination of the URL
Okay,
thing.
you want a spoiler alert
Yes.
on how to solve huge scripts? Okay. What if we store files on chain?
Ooh.
Okay, it's done. Since more than 2 years now.
For more than 2 years.
We will get there on the afternoon.
Okay.
It's an on-chain file system, which is our decentralized GitHub on Cardano blockchain, where wherever does not fit on your QR codes or on your links, you can put it there
Right.
for you to also share with other developers as a GitHub on-chain on Cardano. This is called GCFS. GameChanger.Finance. Sorry. but we will talk about this on the afternoon. But
Okay.
It's a great question, and yes, you're right. You should try to do this as short as possible, and whatever does not fit, try to move it on chain. Okay? Or maybe you can figure out on some other ways. But yeah. Okay. Go.
You want to,
He's like
He likes to go forward all the
yeah,
time.
there's more to say, yeah.
very quickly. Do you want to explain the part?
Well, if you know a little bit more about the raw transaction builder, you would need to balance your whole transaction. Inputs and outputs need to be exactly the same value. So GameChanger will already get the necessary UTXOs from your wallet via smart selection. And that is what it does with the assets. So you're requesting assets, GameChanger will look at your, that's why we needed to do an airdrop. If you don't have any coins, you can't select entry. But GameChanger will also create the UTXOs and create a transaction that keeps your wallet healthy. And that means it keeps a reasonable amount of UTXOs in your wallet. So that's what the transaction builder does. It does more for you. So it makes also the developer of the DApp, his life, much easier. And users sometimes. Because you have heard some stories of people who are like, have some kind of thing happened where the wallet is too many UTXOs, so nobody understands what's going on in the wallet, or there's something else different. And in that case, it's always up to the DApp developer to make the right choices. And with GameChanger, you have some central point where the choices are always the same, and the developer has always a high standard of keeping your wallet healthy.
And it happens automatically, behind the scenes, you don't.
Yeah, if the wallet, the builder will see you have only one UTXO, it will make more for you.
Oh,
Right, okay.
so
And
you don't
this,
need to go to Oxford anymore.
The idea is to avoid delegating the apps. Things that you should be caring yourself, or the wallet should be caring for you. Because UTXOs, for example, when you need to use UTXOs, you need to use the funds on your wallet. Depending on the structure and how these funds has been returned back to your wallet, you make a transaction, right? And the change output, the change back comes back to your wallet. But if on other cases, on other systems, the apps design this change back, right? And this design can harm your user experience. So here on GameChanger, we are in advance. We are like sieving new UTXOs for you all the time for having a healthy UTXO set. And this is important because when we reach on the afternoon, the part where we're talking about the GameChanger file system, you will understand why this is important. Because if you want to store an image on Cardano, it won't fit on one transaction. You have to split it among many transactions.
Thousands.
And this is why UTXO set, one selection, is important for us. And we keep always, we try to keep always healthy UTXO set for you.
What is the name of that application that helps you with that? Like break on personal. What is that a safe thing to use? I'm scared of using that thing.
No. I think I cannot say if it's safe or not. I think it's safe. I've listened to a lot of
Other people saying it's fine.
yes, and the thing is that
It's scary.
that's needed because on other
Makes life
wallets,
great,
other wallets are delegating this to the apps, and the apps are messing all the time.
I think what you also can do is put all your assets in one transaction and send it to yourself.
And it
Then
reorganizes.
Yeah, because then you only have one UTXO in your wallet.
Or use GameChanger.
Which is actually right, because you can connect, for example, Nami Eternal to GameChanger actually, and then you can just you just connect the wallet like on any other VR. You will see. Maybe then we can test that. But the idea is that you can do then one transaction to yourself, for example, and that's it. GameChanger should trigger this healthy, the
And
fixing.
then just restructure.
Can I just check my assumptions here from what you just said?
Yeah.
You made the comment that DX messed with the UTXO output set.
Yeah.
Is that because then you're saying, hey, we're doing good coin selection within GameChanger? So my assumption here is that you're saying that the DX developers, because they don't have the context of the wallet that you're working with, they can't build a proper output.
Well, they get, a DApp will get usually all your UTXOs.
Yeah.
In this case, GameChanger Wallet does it in your browser.
But I'm just trying to get the understanding.
And they have to create their own logic, so they could do anything.
I can tell you that
They
the
can take-
Eternal, Typhon, Nami, none of them are able to select it, but you always have to send yourself the money back if you want to do like transaction that's bigger than your your one UTXO. And I guess this is now trying to solve it. Like it
So
combines UTXO.
UTXO selection is not a simple task.
Yeah, I know that. I've coded it myself. So I'm just curious.
No, just
about-
saying also for the
Yeah.
rest. So a DApp, which is maybe coded by somebody who is not that great at programming, can create 1 million UTXOs in your wallet
Yeah.
by accident.
Right, right.
And you won't even see it, that it happens. You just click sign and.
Yeah, you care about the balance and yeah.
So what you're saying,
Yeah.
what you're saying within the context of GameChanger is, hey, we've done a smart coin selection system, we've made it consistent, everything else like that, whereas there's a lot of inconsistencies in the coin selection algorithms that have been implemented in.
I think it's smarter to keep the coin selection algorithm at the wallet.
Yeah.
Because the wallet
Has that
builder
context.
is usually a much bigger expert at UTXO selection than the app developers, which want to do a whole different task. And
I get you.
coin selection is a single task which you don't need to let 1 million people do. Because you're duplicating effort.
Makes sense.
Since 2021, 2021, we introduced two concepts. Of course, coin selection was something that Cardano was using on DSL already, but we introduced the concept of change optimizer, which is also something similar to coin selection, but the other way around. It's like these are sort of algorithms that helps you program in advance the UTXOs that are going to come back to your wallet. The change outputs, the change that is going to come back when you make a payment, this change come back to the wallet for this change to come back in a way that is healthy. That is not going to mess your future transactions. Because for Cardano, we depend on this transaction history. We are calling this UTXO. When we talk about UTXOs, is this. So
Yeah,
going back
you're
to you.
extending the coin selection to optimize
Exactly.
the overall health of the wallet by working out what the change.
Keeping the balance.
And it's balancing. And because you were coming today, guys, and you were quite a lot for consuming it at the same time, I sent 1 or 2 transactions from the testnet faucet today to this airdrop wallet, and I did not have enough UTXOs. So this is why most of you, or some of you, were competing over the same change outputs.
Right.
And some of you have been experiencing this error today regarding the airdrop, because, I mean, the testnet airdrop system is just for testnet. It's not something super, you know. But yeah, this is important because every single one of you may have contributed to add more health to that, you know, common treasury system for the airdrop. Yeah, just that.
Muy bien.
So reducing the
Last
amount of
thing.
dust in the chain, basically. Yeah.
Last thing, very basic steps. We need to send funds to someone else. 3 questions. Who, how much, and where? I mean, who, how much, and what? Sorry. Who, how much, and what? Right? So, who? We pass here, on this argument, we pass the address of the person that will receive our payment. This is the address, right? Then, the what we want to send. So we have to define which coin or token or NFT, the asset we want to send. In this case, when you say ADA and ADA here on policy ID and asset name, which are 2 things that are very Cardano-ish, our terms are very from how Cardano works, and those defines the tokens and the next native coin of Cardano. So by using these 2 parameters, these 2 properties, we are saying what we want to send.
That's the what?
That's the one. If we say ADA and ADA, we are going to be sending ADA. In this case, remember, it's testnet ADA, because we're on testnet. And finally, how much? The quantity.
Why do you need to like policy ID and asset name to define why not just one, like policy ID or something?
Because some systems, I mean, for tokens and for NFTs, you need both. You always need both.
You
Policy
can have
ID is
multiple
usually
assets on the
hash.
same policy.
Sorry, Teo, say.
I think you can have multiple asset names by the same policy.
Exactly.
Especially with the tokens.
Exactly.
The policy ID and the asset name.
But the thing is that some systems used to use ADA here as a special case for defining the coin of the chain.
Okay.
So when you say ADA here, both on asset name and policy ID, you're referring to the coin of the wallet. And here the security happens because you cannot pass ADA for referring to any other token. Because here you usually pass a hash.
Right.
So here there's no way to confuse, to get confused or mess it up because you say ADA there on policy ID, it's ADA. And finally, quantity. We will explain this later, but 1 million here, this number is 1 ADA.
Yeah, it's
Remember that.
Lovelace.
So it's like our cents, our subdivisions.
Or Satoshi.
Yes, like Satoshi's and Bitcoin.
Okay.
So 1 million Lovelaces equals 1 ADA. And this is expressed
The lovelies.
and Lovelace. So just keeping it simple, 1 million is 1 ADA.
So the part
No.
of the part of the return address and the amount of ADA that's left is also optional because
What part? What do you mean?
yeah, normally it subtracts, right? So you got 500 ADA in your wallet and you send 1 ADA and it subtracts and the rest you need to send back to your own.
Yes, it's automated.
Yeah.
That's automated.
Yeah.
And the thing is that you will see, you can review this always prior accepting everything, review the transaction. You will see how on some cases more than one change output will appear without you expressly saying so. Because there is the wallet trying applying change optimizer algorithm to try to fix to make your UTXO more helpful. That is the magic.
On the transaction builder of the CLI, you can
I use
change address
Yeah,
is always the wallet.
Your own wallet. Yeah.
And this thing for ADA.
Yes, included. But you for
Because, for example, some APIs, when you query the blockchain with some APIs are using this standard. And remember, GameChanger is very old, it's from 2021, so at the beginning, I don't remember if it was Cardano GraphQL or some of those early APIs were using this, so we stick to this. What? Just remember this and you-
originally it was other in this.
Okay.
No, it's a question.
No, I mean, we don't
Te preguntaba. He was asking you.
In Cardano, it was originally interest free or other. No, it's a
It's a
question.
question. Now, I'm not. I don't remember on the seaboard of the transaction. I don't remember exactly how that is
In Bluetooth,
expressed.
you can also do ADA.
But I know it's. No, yes, I think he is mentioning the seaboard structure. I forgot right now. We can check that.
I mean, in truth, it's
Do they replace ADA for something? Or it's I think it's empty. Empty string.
Yeah.
You have built-in seaboard to JSON. Or even a link to go to a seaboard deployed online on the transaction review UI. So we check this later. So that's it. This is all you need to make a payment on Cardano. Let's move on now. Sorry.
It's time for a break. I got
Fine too.
I heard it's time for a break, so time submit.
No, I will do this super quick.
Yes.
You got 5 minutes.
I have less, 2 minutes. Sign. How do we sign? The function is sign transactions. This is more than one if you want. And once again, this is ISL, inline scripting language. Remember, the get function retrieves the result of the, for example, of the previous function, in this case, build one is here. So the result of this function is the draft, the transaction without the signature. So you are connecting, planting the output of this function here as an argument here for the sign transaction using this line of code, which is ISL, which is inline line scripting language. Okay? So this is how we connect them. This is how you provide the transaction for the sign transaction to sign. Then we do the same trick with the submit transactions, which is function against plural. We can pass more than one, and we connect the output of the signed transaction, which is the transaction structure, plus the signatures of the user approving the transaction. That piece of data, you're plunging it, you're connecting it, or passing it from here to here, again with the get function cache.sign2, because this is sign2, we name it.
Right.
When you reach here, at this point, you execute this,
At the point of no return.
point of no return, unless you don't have internal connection. I prove that you're right, and that's it, Break.
When the transaction will start.
Okay.
The point of the if you go one slide back.
Can I have the previous one?
Te podemos pasar el link de los slides.
Sí, también. Pero escribirlo a mí me
Te ayuda mucho.
a entenderlo. Pero parte de los...
What we saw first
Right.
was
Yeah, so cash refers to anything in the wallet memory. Well, no, it's like,
het is niet dat je ergens iets
yeah, there's always, yeah, you have to tell, like, you can also do a put and push that information outside. Instead of like abbreviating it, you have to get wallet. It's like, I don't know, like, it's like let the volume have a hustle and that will like push that information to it's automatically memory, but like you can either submit that back outside of the application or you can present that right to the application itself. So like get something like, yeah, you're retrieving information that's within the application.
Yo soy, ¿verdad? O sea, yo hice como que es un pecado mío. Internal.
Then you're doing yeah, memory, you can basically identify what's going to be
dat is dit getal. Ik zou ook gewoon een getal willen copy-pasten.
right, and then that build one. Yeah, it's like the last, so
Eso tiene que estar.
Wordt dan weer een stuk meer meegenomen. En dat wordt dan weer blockchain. Je zet dit
oh yeah.
So this is
Martin, can I see the next slide? Why do you, so here that's complete. Why do you use these brackets here and here you don't? What is
Because it's a list, so transactions can be a list of transactions.
And this is just a
You could build multiple, and you get more transactions, and you can have
So you
build
get
1, build 2, build 3.
Okay, thank you.
Yes, and the only thing on trade is yeah, and you got the technically you don't have that cash, whatever, just recording values what's back to the user is what's happening on the state. Right, so it wouldn't be necessarily when you're using the GC security, yeah, that's just the implication. But that's what I wanted to
Pero esto sigue después, ¿no?